Now, as far as negative numbers are concerned, we can visualize them on the real number line. So I draw a straight line here, and I mark the center with 0. The numbers that go off to the right are positive numbers. The numbers that go off to the left are negative numbers. If this is a distance of 1 in the positive direction, that's a distance of 1 in the negative direction. So you can see the positive numbers are 1, 2, 3, and then any numbers in between them, and the negative numbers go -1, -2, -3, so on and so forth. Now we say that -2 and 2 are opposites. Sometimes we call them additive inverses, but most of the time we're going to call them opposites. We use this notation to stand for simply the distance a number is from 0 on the number line, and it's called absolute value. So the absolute value of -2 is simply 2, because it's the distance between 0 and this number on the number line. So absolute value is the distance a number is from 0 on the number line. And then we can use these inequality symbols to write down the relationship between a couple of numbers. -2 is less than +2. So if we compare any two numbers on the real number line, the one that's on the left is always smaller than the one that's on the right. So since -2 is over here and +2 is up here, then my inequality is going to say that -2 is less than 2. My inequality symbols always point to the smaller of the two numbers being compared. Let's go to the board now and work a couple of problems. Here I want to write in words, and I have this statement: 4 is less than 7. So remember, this inequality symbol points to the smaller of the two numbers, so 4 is less than 7. 4 is less than 7. Problem number 2, 0 is greater than -4, and that's true, isn't it? I'm pointing towards the smaller of the two numbers, and -4 is a smaller number than 0. So I'm going to read this: 0 is greater than -4. So if I say 0 is greater than -4, that's really the same thing as saying -4 is less than 0. So you don't always have to memorize these symbols as long as you realize that they point to the smaller of the two things being compared. Here's our next problems. Give the opposite. What is the opposite of 3? The answer is -3. So opposites are the same distance from 0 on the number line, but in opposite directions. What is the opposite of -5? The answer is +5. Or I can use this notation, the opposite of -5. So here I have -5. I want to find its opposite, so I can just put a negative sign in front of it, just like I did with the 3 up here. Put a negative sign in front of it, and I've got -3. So 5 and the opposite of -5 must be the same thing, and here we're beginning to get a property that we would use in algebra, and if I wrote it as a property, I would say this: the opposite of -a is equal to a, so that I could show that it was true for all numbers on the number line represented by the letter A. Here's our next problems. We want to place a less than or greater than symbol between each pair of numbers, and we want to do it so that the resulting statement that we get will be true. All right, comparing 3 and 7, 3 is a smaller number than 7, so it's going to point in that direction. Comparing 7 and -5, -5 is to the left of 7 on the number line, so that will be the smaller number. So I simply want my inequality symbol to point to the smaller of the two numbers being compared. Next I have -6 and 0. Well, -6 is the smaller number, so my inequality will point that way. My last one, I have -10 and -100. -100 is the smaller of the two numbers, so my inequality symbol will point in that direction. Next, I want to go simplify some expressions that involve absolute values and opposites. And remember, absolute value is the distance a number is from 0 on the number line. Problem 9, let's find the absolute value of 2. The absolute value of 2 is its distance from 0 on the number line, which is just 2. Absolute value of -8. This is the distance -8 is from 0 on the number line, which is 8. Now this expression, we just worked with this a little bit, the opposite of -2. Well, the opposite of -2 will be +2. Here's a similar expression, but it has a different meaning. What is the opposite of the absolute value of -2? Well, the absolute value of -2 is just its distance from 0 on the number line. So this is the number 2, and its opposite is -2. So you want to be careful. These symbols that we use to specify different things actually mean different things. So this expression right here has one meaning that turns out to be 2 when we simplify it. This expression, when we simplify it, is -2. Now, both of these answers are correct, and your job is to convince yourself that they're true. Now, I got a couple more things that I want to do, but I'm out of board space here, so I'm going to walk back over to the other board and put some things up. So here we go. What we want to talk about right now are the study skills for this chapter, and number one is we want to continue with our schedule. So if you find that you've put yourself on a schedule, you did well on the material in Chapter 1, and did a good job with it, got a good grade on a test or whatever, then you want to continue to do that. Don't become overconfident and cut back on the amount of time that you're studying. If you've done well in Chapter 1 and you've set aside a certain amount of time, stick to that schedule. Increase your effectiveness, that's number 2. Look at those things that you do while you're studying and pick out the ones that are most beneficial for you and increase the amount of time you spend doing those things. The things where you just kind of were spinning your wheels or not getting a lot done, decrease those activities. So you want to become more effective with the amount of time that you spend studying. 3, start listing the difficult problems. You'll see that there will be a certain kind of problem that will come up again and again that you'll have difficulty with. Take a separate piece of paper or pieces of paper and start listing those problems and their correct solutions so that you can go back to them before you study, like the night before an exam, and get those things straightened out. The last thing here, and this is just, I want to just start you on this, don't always trust your intuition when it comes to mathematics. You'll see when we get into subtraction of negative numbers that trusting your intuition isn't always a good idea until you've had a lot of experience working problems. So it's just something to keep in the back of your mind that your intuition on things may not always be correct when it comes to the algebra that we're going to be doing. The last thing I want to do is look at what is called a scatter diagram and a line graph. So I've written a problem over here on the board that has to do with the record low temperatures in a certain city for each month of the year. And so the record low in January was -36 degrees, February -30, March -14, so on and so forth. I want to take this table of values and go over here and draw what is called, or produce what is called, a scatter diagram, and then from that we're going to get what's called a line graph. So you can see that I've set up my horizontal axis right here, and instead of writing the days of the names for the months, I've just written the numbers 1, 2, 3, 4, 5. So 1 is January, 2 is February, March, April, May, June, July, August, so on and so forth. I notice that my temperatures go from about -40 up to around 35, so I've drawn my vertical axis here as a vertical number line with 0 in the middle, positive numbers going up, negative numbers going down. Now what I want to do is go through and put a dot at each that will represent each pair of numbers right here. So for January, I want to put a dot at -36 degrees, and these are degrees Fahrenheit, by the way. So for January, the temperature was -36. I'll go down here to 30. That's 40. Here's 35. So I'm going to go right down here to -36 and put a dot. February is -30, so that's month number 2, down to -30 degrees. That'll be right here. In March it was -14, so here's March, -10, -20, -15, so -14. And for April it's -2 degrees, so I'll go over here to April. There's -10, there's 0, so I'm going to put a dot right about here, -2. For May it's 19 degrees, so here's 10, 20, and so I'm going to go up to about 19 right here. And then June, 22 degrees. So June is 22. Put it right about here. July, 35. So June, July, 35. Right there. August, 30 degrees. So that's the 8th month. 30 degrees. That'll be right about here. And September, 19 degrees. So 9 and 19. Let's see, I want to go straight up. 10 is 15 degrees, so straight up from there. 11 is -11 degrees, so at 11 here's -10, -11. And then 12, -26. So 12 -10, 20, 30, 25, 26. So that will be right here. Okay, this diagram right here that contains the dots, that's called the scatter diagram of the information. And we simply put a dot that represents the information in each pair right here. So January minus 36 degrees, that corresponds to this dot. February minus 30 degrees, that corresponds to this dot. Now, from a scatter diagram, we can draw what is called a line graph, and we do that simply by connecting the dots with straight lines. So if I connect these dots right here in order with a straight line, I get what is called a line graph of that information. Now, we could have also drawn a histogram for this information. Let's get this one here, and then down here. So there is a line graph of the information that's in this table right here. So as far as representing information graphically, we have three things that we can use right now: histograms, scatter diagrams, and line graphs.